Hello everyone, welcome to another math tutorial. Okay, now here we have a system of equation. That is, we have two equations, simultaneous equations. Okay, and the first equation is we have x raised to the x plus y equals to y raised to the raised to the power of 40. This is equation 1. Okay, so that's the first equation. Then the second equation is y raised to the power of y plus x equals to x raised to the power of 10. And this is equation 2. Okay, now our task is to find the values of x and y, as x, y are elements of set of positive integers. So that means the value of y, the value of x must be positive. All right, so in this case, I'm going to start with from equation 1. So I'll say from equation 1. Now we have equation 1 to be x raised to the power of x plus y equals y raised to the power of 40. That's equation 1. So what I'm going to do in this case is, now I'm going to express y in terms of x. And to do that, I need to get rid of power 40 so that I can express y in terms of x. So which means I'm going to multiply the powers. Okay, multiplying the powers, or we can say the exponents, okay, by 1 over 40. So this will be x raised to the power of x plus y multiplied by 1 over 40 equals to y raised to the power of 40 multiplied by 1 over 40. So 40 will cancel 40. So we'll be left with y equals to x raised to the power of x plus y, okay, over 40. So let's call this equation 3. So this is the third equation. Now, y equals x raised to the power of x plus y divided by 40. So I'm going to substitute for y in equation 2 because I use equation 1 to derive equation 3. All right, so let's substitute. Substitute for y in equation 2. Now, in equation 2, we have equation 2 to be y raised to the power of y plus x equals to x raised to the power of 10. So which means that now that y equals x raised to the power of x plus y divided by 40. So this will be x raised to the power of x plus y over 40, which is y. Then this is y. Then raised to the power of y plus x, then equals to x raised to the power of 10. Now, this is where we can now apply what we call power product rule or power rule for exponent. That is the power rule for exponent. When we talk about power rule for exponents. Okay, power rule for exponents. That is when we have parentheses a raised to the power of x raised to the yth power. So this will be a raised to the power of x times y. That is power rule for exponents. So I'm going to apply that in this case. So this will multiply this. So that means y plus x times x plus y over 40. This will be x raised to the power of x plus y raised to the power of 2 over 40 equals to, then on the right hand side we have x raised to the power of 10. Now we have the same base on both sides, so this will cancel out, then this will reduce to x plus y raised to the power of 2 divided by 40 equals to 10. Now in this case, to get rid of 40 on the left hand side, okay, I'm going to multiply this equation. I'm going to multiply this equation by 40. So that means 40 times x squared of x plus y, okay, divided by 40. This will reduce to x plus y raised to the power of 2 equals to 40 times 10. This will be 400. Now let's get rid of the power. So in that case, we're going to what? We're going to take square root. So taking square root of both sides. taking square root of both sides. So the square of x plus y, okay, will be equals to plus or minus square root of 400. So this will be x plus y equals to plus or minus 20, because the square root of 400 is 20. Okay, now let's not forget that x, y are elements of set of positive integers. So we're going to write two equations in this case, which will be x plus y equals to 20, or x plus y equals to minus 20. So we're going to reject this. This will be rejected. Why? Because I said the values of y and x must be what? Positive. All right, so this will be our equation 4. So x plus y equals 20. This will be equation 4. Now that x plus y, the value of x plus y is 20. So if I plug in the value of x plus y into equation 3, okay, that is substitute, or let's say plug in the value of x plus y into equation 3. So this is equation 3. We have y will be equals to, now we have x raised to the power of x plus y divided by 40. So this will be y equals to x raised to the power of 20 over 40. So this will be 1 over 2. So which means x will be equals to, so x will be equals to y squared. X will be equals to y squared, because from here y equals to x raised to the power of 1 over 2. So x will be equals to y squared. Okay, so this is when we can now substitute y squared for x in equation 4. Okay, so substitute y squared for x in equation 4. So what is our equation 4? X plus y equals 20. So we have x plus y equals 20. That's equation 4. Now x equals y squared. So this means we're going to have y squared plus y equals to 20. So I'm going to bring this to the left hand side. So this will be y squared plus y minus 20 equals to 0. Okay, so now in this case, we have a quadratic equation, so we can use factorization method. And the factors of minus 20, okay, that when added together will give us plus 1. That will be 5 and minus 4. So in this case, this will be y squared. Okay, this will be y squared plus 5y minus 4y, then minus 20 equals to 0. So that this will be y squared divided by y. That will be y. 5y divided by y. That will be plus 5. Then this will be minus 4 into y plus 5 equals 0, because negative 4y divided by minus 4, that will be 1y. Then negative 20 divided by minus 4, that will be plus 5. So this will be y minus 4, then y plus 5 equals 0. So I'm going to set y minus 4 equals to 0, and also y plus 5 equals to 0. So this will be or y plus 5 equals to 0. So this will be y equals to 4, or y equals to minus 5. So this will be rejected. Remember, I said as x, y are elements of set of positive integers. Okay, so in this case, so the only value of y, okay, that will be possible in this case will be what? 4. All right, so let's get the value of x. Now I'm going to use this same equation. Okay, so we know that x plus y equals to 20. Now y equals to 4. So we have x plus 4 equals to 20. Okay, so that means that x will be equals to 20 minus 4. So the value of x is 16. So we can say x equals 16, then y equals 4. So these are the two values, okay, the values that will satisfy these equations. Now let's verify our answers. Let's verify our answers. Let's verify. So for equation 1, we have this to be equation 1. The left hand side from equation 1 will be, is what we have to be x raised to the power of x plus y equals to y raised to the power of 40. Now the value of x is 16. Then the value of y is 4. So when we say x equals 16, then raised to the power of x plus y is 20. Then the value of y is 4. Okay, raised to the power of 40. Then I can write 16 in terms of base 4 to be what? 4 raised to the power of 2. Yes, so that means in this case, this will be 4 raised to the power of 2 raised to the 20th power, then 4 raised to the power of 40. So when this multiplies this, okay, so that means we're going to have 4 raised to the power of 40 on both sides. Now, for equation 2, we have the left hand side, okay, to be, for equation 2, we have the left hand side to be y raised to the power of y plus x. Okay, why the right hand side? Okay, this is the right hand side in this case. Okay, so the right hand side is x raised to the power of 10. So this is the right hand side. Now, the value of x is 16. The value of y is 4. So the value of y, which is 4, raised to the power of 20, because x plus y is 20, equals to the value of x, which is what? 16, then raised to the power of 10. Now, we know that 16, okay, is the same as 4 raised to the power of 2. So we can say 4 raised to the power of 20 equals to 4 raised to the power of 2, then raised to the power of 10. This will be equals to 4 raised to the power of 20 equals to 4 raised to the power of 20. So which means the left hand side and the right hand side are equal. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.